Hi, my name is Darshan and I'm an online tutor of math and physics. This is the first FRQ of 2023 AP Calculus BC exam. This is part A, so the calculator is allowed. Let's start. Let's start working on this question. This is based on integral calculus, application of integration. It says that there is a customer at a gas station who is pumping gasoline into a gas tank. All right, and the rate of flow of the gasoline is modeled by a differentiable function f, where f is measured in gallons per second. So this is important, that f in itself is actually the rate at which the gallon is pumped into the tank. So I'm going to highlight this part. And t is measured in seconds. Fair enough, t is measured in seconds since the pumping began. Selected values of the function ft is given in the table. So here we are given a table where the value of ft is given for some values of t. Using correct units, interpret the meaning of this guy. In the context of the problem, use a right and Riemann sum with 3 subinterval this to approximate the value of this integral. All right. So first off, what are the correct units of this guy? I'll tell you a very easy way to find the units. Notice this ft. What is the unit of ft? That is gallons per second, correct? Gallons per second. So per second would definitely means that we divide this with seconds, so per second. And then you multiply with dt. What is the unit of dt? dt is nothing but time, right? And what is the unit of time? That's seconds. These two are gone, you're just left with gallons, which perfectly makes sense because the integral of gallons per second, so integral of a derivative is going to give you that function itself, right? So it's going to eventually give you gallons, and we have sort of proved it mathematically as well. So the unit of whatever we get is gallons. So this is something which we have proved. And now, in fact, let me keep this as it is. And now we are going to use the right and Riemann sum. Fair enough. What is the difference, or what is the rectangle's width of the Riemann? So 90 minus 60 is 30. 120 minus 90 is 30. But here it's not 30, right? Be careful. It's 15 units. So that's fine. Where there are three subintervals, so we just have to find the area of each of the rectangle, right? So the integral from 60 to 135 ft dt, okay, we are going to interpret the meaning of it as well once we find the value. This is going to look like the area of the first rectangle, which is going to be the width, which is 30, multiplied by its height, right? And what is its height? Its height is going to be f of 90, because we are talking about the right and Riemann, plus once again 30 times f of 120 because of the same reason. And in this case, we will have 15 times f of 135, once again because that's right and Riemann. It's all a matter of plugging in the numbers. So we need 90, 120 and 135, all of which are given in the table. So 30 times 0.15 plus 30 times 0.1 plus 15 times 0.05. All right, calculator is allowed. So let me just grab my calculator. You can fast forward this this particular section of the video. Plus 3 plus 15 times 0.05. That's going to be 8.25. This is what I'm getting, 8.25. And what is 8.25? We already defined that, right? This should be gallons. So this is 8.25 gallons. And what is the meaning of this? It means that between 60 and 135 seconds. Why 60 and 135? Because notice these limits. The lower limit is 60 and the upper limit is 135. So between 60 and 135 seconds, I'm going to write the interpretation over here, that between 60 and 135 second, gallons pumped into the tank is equal to 8.25. This will be the significance or meaning of actually what we got as the answer. All right, okay, so this makes perfect sense. I hope so. Let's move on to question number 2. Now they're asking that must there exist a value of C for C between 60 and 120 such that f prime C is 0? Justify your answer. This is a classic case of Rolle's theorem. Actually, I need this table once again, so I'm going to borrow this from this page and paste it right here. Okay, it's already given in the question. I'm going back again to highlight something. It's already highlighted, it's already given in the question that f is a differentiable function. And if f is differentiable, by default, it means that f is continuous. So I know that f is continuous. I know that f is differentiable, and on the top of it, f of 60 is equal to f of 120. It's evident, right? It's intuitive. Both have a value of 0.1, f of 60 and f of 120. And don't you think this is a classic condition of Rolle's theorem? Rolle's theorem. Let's remind ourselves what is Rolle's theorem? Rolle's theorem says that if a function is continuous, a function is differentiable, and fa is equal to fb, where a and b are some values, then there exists at least one value of c between a and b such that f prime c is 0. In this case, the value of a is 60 and the value of b is 120. So there exists at least one value of c such that f prime c is 0, where c is between 60 and 120. So this is how we can justify. They ask us to justify, and this is how we are justifying that the Rolle's theorem is applicable, and using Rolle's theorem, this must be true actually. Right, I hope it makes sense. Let's talk about the next question. The rate of flow of gasoline in gallons per second can also be found by this particular model. So they have given a function that, okay, the rate of gasoline is also given by this. Using this model, find the average rate of flow of gasoline. Average rate of flow of gasoline over the time interval 0 to 150, and show the setup of your calculation. Let's ask ourselves, what is the value of the what is the expression for the average value of any function fx? So average value of fx between any two values, let's call it a to b, is nothing but the integral of fx over b minus a. That is a very simple formula for the average value of a function between a and b. Right, as simple as we are going to use this, plug this in into the calculator and get our answer. So in this case, I believe the function is t over 500 cos of t over 120 square. This should be integrated between 0 to 150 because the limits are already given in the question. There you go. Obviously there comes a dt here over the upper bound, which is 150, minus the lower bound, which is 0. We just have to plug this into the calculator, so bear with me. I'm gonna use my calculator and find this up. Please skip or fast forward this portion. It's gonna take about 1 minute for me to find, and once I do that, I'm gonna put the calculation as well for you to check. So it's t over 500 cos of t over 120 whole square dt over 150 over 150. I have to make sure that my it's in radian, so it is indeed in radian mode. So the answer which we are getting is so I think I found the answer. Let me just pull this up. Okay, this is what I'm getting. Just want to make sure that I've not messed up anywhere. 0 to 150 t over 500 cos of t over 120 whole square and dt divided by 150. So I think everything is in place. So I'm getting 0 0.0677 up to 4 decimal places. Use this model, find the average value. So this is the average value, the rate of the flow of gasoline. Yes, average rate of flow. This is the average rate of flow of gasoline. So obviously the unit is going to be gallons per second. This is going to be the unit. So this is how we solve it. And the last part is using the model G defined in part C, find the value of G prime 120 and interpret the meaning. Okay. So it's as simple as you just have to find the derivative of this particular function at t equal to 140. So that should not be a problem for us because that's calculator the calculator intensive question. I'm just going to go back and put the find the derivative of this guy and plug in 140 in it. So give me just 1 minute. All right. Once again, I'm going to show my calculation, of course. So let's do away with this. This is G of t, and I need the value of G prime 140. So this is what I am getting. This is the value of GT over 500 cos of t over 120 whole square. So this is G prime 120. Let me just pull the screenshot up on the board. So this is what I'm getting. This is GT t over 120 t over 500 cos of t over 120 whole square. G prime 140 is what we have here. So the value of G prime 140 is going to be negative 0.00138. What is the unit of it? Remember that we are finding the derivative of something which was already giving a change. So it was gallon per second, and we are again finding a derivative with respect to time. So it will be gallon per second square. And how will we interpret this? We'll interpret by saying that the rate of flow of gasoline is decreasing. In fact, I should start my explanation with at t equal to 140 seconds, because that's where we are solving, right? So at 140 seconds, the rate of flow of gasoline is decreasing at the rate of negative 0.00138 gallon per second square. So this should be the answer for our part D. I think this was the last part for this question. Please let me know in the comment section if you feel like you're getting a different answer, if I've messed up the calculation somewhere. And for any comments, please feel free to reach out. And if this video was helpful to you, please subscribe to my channel. Bye-bye.